Assalamualaikum and a very good day. My name is Nur Hazana Faria binti Ahmad Kamal with metric number S52084. Today I'm going to present a lab report for module 4. So basically in this module 4 we're going to do the lab report based on lab 3 and lab 4. Okay, now I'm going to start with lab 3. In lab 3, the selected project is RGB LED running light and DHT11. So for RGB LED running light, to form the circuit is the needed equipment is ESP32 breadboard, USB cable for male to female jumper wire, RGB LED, and 1K ohm resistor. So as you can see, the figure below is the circuit that has been formed in this project. Okay, this is a source code for RGB LED running light. The pin number that I've used for the three color for this LED is pin 21, pin 22, and pin 23. So the code below follows by the sequence of the LED color that needs to be light, and once the LED 1 value is 1 means LED 1 color will be bright and the other two color will not light up. So follow by the sequence of the next color. Okay, this is a final output of the RGB LED running light. As you can see, the color change follow with the sequence of the source code. The next project in lab 3 is the DHT11 sensor. The circuit needed is ESP32, USB cable, 3 male to female jumper wire, and DHT11 sensor. So figure below is a circuit to proceed to the project. This is the source code of the DHT11 project. The pin that has been chosen is pin 15 for DHT11, and the sensor will display the temperature in degrees Celsius and the temperature also in the Fahrenheit and the humidity, and if there any error with the sensor, the system will print fail to read the sensor. So this is the output that we got from running the previous source code. So this shown the temperature in degrees Celsius and the temperature also in Fahrenheit and the humidity in percent. So this sensor will refresh within every 2 seconds. So we're going to proceed with lab 4. In lab 4, the first things we need to test the ESP32 whether it can connect to the Wi-Fi or not. The equipment needed for this circuit is only ESP32 and USB cable. This is a source code to check our ESP32 to connect to the Wi-Fi. SSID and password is your own Wi-Fi password and Wi-Fi name. So if the ESP32 can connect to the Wi-Fi, it should be print network config with the name and password of your Wi-Fi, follow with the connected message. This is the output shown when the ESP32 is successfully connected to the Wi-Fi. Okay, after that we're going to proceed with the ESP32 MQTT. After we successfully connect the Wi-Fi to the ESP32, and now we're going to connect with, we're going to send the data from UPiCraft itself to the Favor IoT by using MQTT. Okay, first of all, we're going to create a new device in Favor IoT. So that later we're gonna use device developer ID and access token in the code in our source code to proceed with the project. So this is the source code for MQTT test, and we're gonna import the MQTT client from umqtt simple, and the server is the mqtt.favoriiot.com itself, and the client is our MQTT client, and from the MQTT client server means the user, and the password is our access token from the device that we create in Favorite IoT. So Wi-Fi and password is our Wi-Fi, and device developer ID also from the device information from Favorite IoT that we create before. Topic also from access token from Favorite IoT device also. So this is the output that's shown in UPyCraft itself. The OK output means that the data has been sent to the Favorite IoT data stream. Okay, as we can see, the data is successfully sent to the Favorite IoT data stream, and the data will be sent within 5 seconds and refresh every 5 seconds. Finally, in this lab, we're gonna learn about subscribing data from MQTT broker Favorite IoT. The equipment needed is also ESP32 and only USB cable. This is a source code for subscribe training. We also use the same access token and device developer ID from previous tasks. This is the output shown when the subscribe training is successfully done. That's all from me for Module 4 lab report. Thank you.